Hello, today we are going to discuss about IPv6. As in previous class we have discussed about its address notation and why we need the IPv6 addresses. So in this class we will learn about the IPv6 header format or the packet format, and it's about extension headers and the advantage of IPv6 addresses and type of IPv6 addresses used in network. So let's first discuss about the IPv6 packet format or the header format. So this is of 8, it contains 8 fields and it is of 32 bit, and the 8 fields are like version, traffic class, flow label, payload length, next header, hop limit, source address and the destination address. So let's discuss about these fields in detail. The first is version field. The version field is of 4 bit and it remains constant, that is 6. The bit sequence is 0110 to represent the internet protocol version. And the traffic class field, it is of 8 bit and it holds the 2 value, that is 6 more significant bits are used by differentiated services and remaining 2 are used by the ECN. So this provides the information about the quality of service and the about the data traffic information. And next is flow label, and this field is of 20 bit and it is used for giving real-time application special services and also help to detect spoofed packets. Then is payload length, it is of 16 bit, and when a hop by hop extension header holds a jumbo payload option, then the length is set to 0. And the next header, it is of 8 bit long and which it specifies the type of the next header, and it specifies the transport layer protocol used by the packet payload. And when extension headers are present in packet, these fields indicate about the type of extension header used in the packet. And next is hop limit, it is of 8 bit and it is this value indicates that the field decreased by 1 at each intermediate node visited by the packet. So the value of this field decreases as the packet goes from one node to the another node, and when the counter reaches to the 0, this packet is discarded and this field replaces the time to live field that is used in the IPv4 packets. Next is source address, it is a 128 bit long and it indicates the IP address of the source node. And next is destination address, it is of 128 bit and it indicates the IP address of destination node. And next is about the extension header used by the IPv6 addressing. So extension headers are added to give greater functionality to the IP datagram or the IP packets, and it is added with a base header. These extension headers are like hop by hop option, source routing, fragmentation, authentication, encrypted security payload and destination option. So let's discuss about these extension headers. The first extension header is hop by hop option. So it is used when the source need to pass information to all router visited by the datagram or the IP packet. So the jumbo payload option is used to define a payload longer than 65,535 bytes. So the payload which become larger than 65,535 bytes is known as jumbo payload. And the source routing extension header is a method to specify the route to the IPv6 datagram. So it defines the route for the IP datagram or the IP packets in the network. Next is fragmentation. Fragmentation header is used when a packet to be sent is larger than the MTU, that is maximum transmission unit, which a path can hold. So when our data become larger than the MTU unit, so it is divided into fragment or the smaller units, and each fragment is added with the information which is necessary to reassemble the original packet at the destination node, that it is assigned with the sequence number before sending to the receiver. The next is authentication. Authentication extension header contain information used to verify the authenticity of the packet. Next is encrypted security payload. So it is used to contain information which verifies the confidentiality of most part of the packet. It is also used for the security purposes. Next is destination option. Destination option is used to examine the optional information of data packet by the destination node. The next is the advantages of IPv6 address. So it provides larger address space, that it is address is of 128 bit, and it provides better header format, that is the complexity from the header is reduced in IPv6, so the header of the IPv6 become better. Next is new additional option like adding extension headers and security to the IPv6 address. It allows for the extension, and the next is more security to the IP addresses. Next is the type of IPv6 addresses. The type of network communication in IPv6 are unicast address, multicast addressing, and anycast addressing. So first is unicast addressing. So unicast is a type of communication where data is sent from one computer to another computer in a network. So it is also known as one-to-one type of network communication. In unicast type of communication, there is only one sender and one receiver. For example, in IPv6 unicast type of network communication, like browsing a website, where server act as the receiver, which receives the browsing search request, and client is the sender, which sends the browsing request to the server. And next is downloading a file from a FTP server, where FTP server is a sender of the file and client is the receiver of that file. The next is multicast address. So multicast is a type of communication where data is sent to a group of devices in network. In multicast, a group is created and data is sent between these group in the network. Where IPv6 multicast data is sent to a group and only member of that group receive the multicast data. In multicast, the sender transmits only one copy of data. It is delivered to the group of devices. For example, online TV. Next is the Anycast address. So anycast is a type of network communication in which IPv6 datagram from a source are routed to the nearest device or the nearest destination from members from a group server which provide the same services. So every node which provide the same service are configured with same anycast destination address. So in anycast, the nearest destination, the message is sent to the nearest destination from the group of the devices. So this is all about IPv6. Thank you.